Alright, so let's take a look at some unusual examples for electron configurations. So I have a periodic table, I have it labeled, and I also highlighted 5 elements. I highlighted chromium, molybdenum, copper, silver, and gold. These do not follow the normal trends, something which is not typically mentioned in an introductory level class, but for this class I'm going to mention them, and these 5 you need to know. Alright, so if you were to write the complete electron configuration for chromium, what would you expect? You expect it to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, followed by 3d4. And it turns out this is what the pattern would predict. It predicts it to be 3d4. It turns out that is wrong. It turns out that's actually not the case at all. What happens is that one of the electrons in the 4s sublevel, one of the electrons here, gets moved to the 3D. So remember, the 4s is this. So there's my 4s, up, down, 4s. I got my 3Ds. That's 5 of those. 1, 2, 3, 4, 5, with 4 of them. 1, 2, 3, 4. It turns out that one of these guys here gets moved to there. So now I end up with my 4s with 1 electron. 1, 2, 3, 4. My 3D orbitals, each of them now are halfway filled. And it turns out having halfway filled orbitals imparts extra stability. So basically what happens, one of these 4s's moves over to the 3D to give me a new configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. And that's the part that's new. So there's something you need to be aware of when it comes to chromium. Chromium does this. It ends in d4. We take one of the s's out and we move it over. Look at molybdenum. Molybdenum ends in 4d4, very similar to chromium, which was 3d4. An exact same scenario happens here. One of these 5 s's moves over to fill the halfway filled molybdenum. So molybdenum will end with, this is for MO. For MO, we're going to end with 5s1 and 4d5. That'd be what molybdenum will end in. The rest of it will be analogous what we did earlier for chromium. Interestingly, tungsten does not do this. Even though it's in the same column, tungsten follows the rules like normal, so we're not going to worry about this one or seaborgium below it. You may recall tungsten also has F electrons, so maybe that has something to do with this. Now, when it comes to column 9 here, copper, silver, and gold, notice these are all 1 electron away from being properly filled. So when it comes to copper will end with 3d9. Copper ends with 3d9, so let's write that configuration out. So Cu, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9, and if I draw that out, here's my 4s, up, down, 1, 2, 3, 4, 5 orbitals for my 3ds, up, 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 and then down, 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 down. Notice what happens here. I have halfway filled up I'm basically 1 electron away from being full. One of these 4s's jumps to fill it to give me 4s1 3d10. So it will not be 4s2 3d9, it will end in 4s1 3d10. And that's what happens here with all of these. Copper, silver, and gold all behave this way. Now these are not the only elements in the periodic table which are exceptions to the rules. If you look carefully at the periodic table in the textbook, you will find multiple exceptions to the rules, especially in the F block. There could be more in the D block. There's a number of them, but these are the only 5 you are required to know for the test.